All right, looks like we're going on to chapter 5, section 3. So we're going back a little bit with this lesson. I wanted to get taken care of the addition, subtraction, multiplication, and division of just polynomials, because in this section we're going to talk functions and function notation instead. So a lot of the things are going to be the same, adding and subtracting, multiplying, but now we're going to be looking at function and function notation, and we're going to add one little piece onto this kind of as well with functions. So adding, subtracting polynomial functions, recognizing and evaluating functions, those things are kind of done already. The new one, find composite functions, that's going to be a little bit something that we haven't done before. So that's going to be a new one for us. And then we're not going to worry about graphing these too much. So recognizing and evaluating functions, here's kind of what a polynomial function is, and it is, it is what it is of the nth degree and so on and so forth. What we want to be able to do in this piece of it is we want to be able to evaluate functions. Now remember, we talked about functions in the last unit, or unit 3, I think, and we talked about what these different functions were, and that 1x goes to 1y and so on and so forth. But we want to be able to evaluate these polynomials. So when we're evaluating polynomials or we're evaluating functions, anytime we get something in here, that means that's what we replace our x with within that function. So we're given the function f of x is equal to negative x squared plus 5x minus 11. We're asked to evaluate it where x is equal to negative 4. So then anywhere we see a negative 4 or anywhere we see an x in that function, we need to replace it with the negative 4. So essentially we're going to find f of negative 4. Okay. So again, remember when you replace it that we replace it inside of parentheses. So we've got the negative of negative 4 squared plus 5 times negative 4 minus 11. Negative 4 squared is 16, so you get negative 16 minus 20 minus 11, or you get 47 then for your solution. So again, we've talked about it before. Make sure you always put what you're substituting in, put that inside parentheses, and it's very important in this one because if you look at that negative 4, we've got a negative and a negative 4, so that negative 4 inside parentheses has to be squared, making that positive. Okay, and that's essentially doing that. We're not going to look at these. We're going to work on adding and subtracting polynomial functions. Really no different than what we were doing before when we were adding polynomials. You combine like terms, but it's going to be written a little bit differently when we're talking about polynomial functions. So something like this. If x and g are defined functions, and you'll be given those, then f plus g of x is equal to f of x plus g of x. Add them together. And f minus g of x is equal to f of x minus g of x. It's the difference functions. In each case, the domain of the new functions is the intersection of the two of f of x and g of x. So what does that all mean? Okay, so let's say that we have the two functions f of x is equal to 3x squared plus 6x minus 8, and g of x is equal to negative x squared plus 4x minus 8. We are going to find the sum of them, and we're going to find the difference of them. So when we find the sum of them, this is just like finding f of x plus g of x. So my f of x function is 3x squared plus 8x minus 6. My g of x function is negative 4x squared plus 4x minus 8. And I just put that inside of parentheses just to kind of help myself out. Now I combine like terms. Negative 3x squared minus 4x squared is negative x squared. 8x plus 4x is 12x. And then negative 6 minus 8 is negative 14. So there's our solution to f of x plus g of x. If we go f of x minus g of x, so now we're just going to subtract them. So again, we're still looking at that f of x function, but now we're going to subtract the g of x function. and we subtract the g of x function, this is where you have to be careful to make sure that you distribute that negative symbol throughout. That's kind of why it's nice to put parentheses around that second piece of it. So we've got 3x minus negative 4x squared, so that's 7x squared. 8x minus 4x, which is 4x, and negative 8 minus negative 6 minus negative 8, so plus 8, so you get plus 2. So there is our evaluation of f minus g of x. And again, remember these things just mean f of x minus g of x. They put values in there, and we could just solve for the value as well. Okay, so there's adding and subtracting, and in here's just going to be their explanations for them, and they get the same answer as we do. Okay, so now in this one, it's asking us to find each value. So we're going to find f plus g of x, which is equal to f of x. Okay, so, but now they're giving us the negative 1. So we're going to find f of negative 1 plus g of negative 1. So we need to evaluate the f function at negative 1. And then we're going to add that to the g function evaluated at negative 1. So the f function evaluated at negative 1 is 18 times, in parentheses, negative 1 squared minus 24 times negative 1. I'm going to solve that real quick. Negative 1 squared is 1. That's 18 plus 24. Just to get out the calculator real quick, 42. So that's what f of negative 1 equals. Now I'm going to add to that g of negative 1. So anywhere in the g function I see an x, I'm going to replace it with a negative 1. So that's going to be negative 3. So 42 plus negative 3 is going to give me 39 is the value of f of g of negative 1, or f plus g of negative 1. Okay. Now let's look at part B. In part B, they're evaluating at 1 instead of negative 1, and we're going to subtract them. So it's essentially going to be f of 1 minus g of 1. So f of 1, in the f function, anywhere I see an x, I'm going to replace it with a 1. And I'm just going to solve this first. So that's 18 minus 24, because it's 1, because it's just 1 now, so it's minus 24, so that's negative 6, minus g of 1. So g of 1 is going to be 3 times 1, which is just minus 3, which is minus 9. So there are your solutions. That's the way I find it easier to do these. Write it out so you know exactly what you're doing in both cases, and then solve each side and just subtract when you're evaluating these. Okay? So again, and we can see what they did. They may have done it a little bit differently than we did, but they got the same answer. And again, they did it a little differently than we did, but they got the same answer as negative 9. So now the new one, finding composition functions. So composition functions in the format that I used doesn't do this very well. It doesn't recognize it. I put it on a Mac, and this is, it just doesn't recognize it. So what this says is G and then an open circle F of X. And that is equal to the same thing. It's equal to G of F of X. And this is what we call a composite function. If f and g are functions, then the composite function or composition of g of x is defined as, this says g of f of x. So what does all of that mean? Okay, so I need the function here. Okay, so here's our function, our f function and our g function, and we are going to find f of g of x. So this is what they're asking us to find, and don't worry about this part yet. So by definition, well, let's first find f of g of x. So if we're going to find f of g of x, not exactly what they're asking us to find, we're going to find this. What this means is that we know what the g of x function is. And remember, this could be written as f o g of x. These are the same thing, fog. These two things mean the same thing. Well, we know what that g of x function is. We know our g of x function is x squared. So realistically speaking, I could rewrite this as f of x squared because I know what that g of x value is. That g of x value is x squared. So now, by definition, anywhere I see an x in the f function, I'm going to replace it with x squared. So this is just going to be x squared minus 4. And if they're just asking you for f of g of x, you're done. There's nothing left to do with it. Okay? That's kind of that mode of doing these. Okay, so now I'm going to erase all of these and kind of talk about what they asked to do. So their question was find again, rewrite it because of formatting, f o g of 3. So essentially what that means, f of g of 3, means that we're going to find f of g of 3. So you always work from the inside out when you're doing composite functions. So we have to evaluate the g function when my x value is 3. Well, my g function is x squared. So anywhere I see an x in that g function, I'm going to replace it with x squared, or with a 3, I'm sorry. So that means this middle part is really going to be 3 squared. And then I have to find f of 3 squared. Well, 3 squared is 9. So now I have to find f of 9. So I look at my f function, and anywhere I see an x in my f function, I replace it with a 9. 9 minus 4 is 5. So f of g of 3, the solution to that is actually just 5. Okay? And I imagine that's what they'll get. And they did. So let's do a couple more examples. So we're going to find f of g of 2. And we're going to find g of f of x. So here are our two functions. F of x is equal to 3x plus 6. G of x is equal to x cubed. So I have to find f of g of 2. So I'm going to rewrite this as f of g of 2. So I look at my g function, and anywhere in my g function where I see an x, I'm going to replace it with a 2. So this means I'm going to find f of 2 cubed. Well, 2 cubed, 2 times 2 is 4 times 2 is 8. That means I have to find f of 8. Now I look at my f function. And anywhere in my f function where I see an x, I'm going to replace it with now an 8. So 3 times 8 plus 6, that gives me 30. And there's our solution for f of g of 2. Part B is finding f of g of f of x. So I'm going to rewrite this as g of f of x. Well, we know what our f of x is. It's 3x plus 2. So that means I need to find g of 3x plus 6. Now this tells me in the g function, anywhere I see an x, I'm going to replace it with 3x plus 6. Well, g of x is x cubed, so I'm going to put 3x plus 6, that's my new x, and I'm going to cube that, and that's your solution. And you're done. Don't need to work that out. You can just leave it in that mode. And let's see how the book does it. Same answer we got. Same answer we got. And that leads to graphing polynomials, and we're not going to graph polynomials at this point. We are just going to kind of leave it at that. But let's do one more composite function just to make sure you're okay. So let's go f of x is equal to 4x minus 1, and g of x is equal to x plus 7. First one we're going to find is g of f of 7. So g of f of 7, so I can rewrite that, g f of 7. So I look at my f function. Anywhere I see an x, I'm going to replace it with a 7. So that's 4 times 7 minus 1. That means I have to find g of 27. So in the g function, anywhere I see an x, I replace it with 27, and you get 34. The last one, let's find f of g. Now let's just do it of x. So the first thing I'm going to do is I'm going to rewrite it. I got no numbers to substitute in this time, so I know g of x is x plus 7. So that means I'm going to find f of x plus 7. So in my f function, anywhere I see an x, I'm going to replace it with x plus 7, and don't forget the minus 1, and then just simplify. It's 4x plus 28 minus 1, which is equal to 4x plus 27. And there's your solution. Okay, so that concludes kind of today's section 5.3. You should have 5.1, 5.2, 5.3, and now 5.4 that you're able to complete. We've only got one section left to go within this. There's a couple quizzes that you're going to have to take care of, and we will then move on to chapter 6. So I hope everybody has a great day. Stay safe out there, and we will see you next time.